So we discussed this yesterday, but we'll go back over it. We have two triangles, and if all three sides or all three pairs of sides match, then your two triangles are congruent. This one's probably the easiest one. They can also be sharing a side, which we saw in our assignment. They don't need to mark this side because it's the same side, so it's the same length as itself. Reflexive property. Yeah. Okay. We have angle, side, angle. So this occurs when you have two triangles with two sets of congruent angles and the side between them is congruent, and it has to be between them. It always has to follow the same order as the letters. So the angle and then the side between and then the angle. We can have a combined one like that, and they're sharing the side between them. And then you have, yeah, the one that's in the middle that's being shared. So if I were to take these two triangles apart, it would look like this, and then that would be marked. And then we have side, angle, side. My nice straight line there. So I have a side, an angle, and then another side. So these, here I have two angles with a side between them. Here I'm going to have two sides with the angle between them. And these can be shared too. Let me just figure out how I want to draw it. So I have a side, an angle, and a side, an angle, and a side. As I move around, right? Side, angle, side. Now, remember we discussed yesterday that there's no cussing in geometry. Okay? Not just because we don't want you to cuss, but because it doesn't work. It's like and actually it's not a thing. I mean, it's really not a thing. Okay? So we don't have angle, side, side ever. And we don't have side, side, angle. So it doesn't go either direction. Okay? So we have two triangles are congruent because of angle, side, angle. So again, you can either move around the triangle this way, or you can move around the triangle, that's the same direction, this way. No matter which way you move around the triangle, you'll go in order. Angle, side, angle, angle, side, angle. Okay. Three sides. Same thing, you move around the triangle either direction. And here I have side, angle, side, or if I go this way, I have side, angle, side. Okay. And then we talked about finding values that will make two triangles congruent. They're sharing 17. There's a side, an angle, and a side. So in order for this to be congruent, it has to be the same length. And this would be side, angle, side. Okay. Uh-huh. Kind of. But I can draw some more after this. Here, they're kind of showing a vertex, but they're not showing any sides. But if I look at it, I have a side, and then an angle, and then another side, side, angle, side. And here they're sharing this side. So we have side, side, side. Now, a non-example, if I had two that were kind of, pretend that looks just like that. Okay? And I have a mark here and a mark here and then a mark here and then say 3 marks. That tells me that this side and this side are not the same length. So this would, so you have to go by, they have to have the same number of ticks. Okay, so that's really, really important to notice, because while I will not consciously trick you that way. I can't guarantee that book publishers or test publishers would not consciously trick you that way, right? So you want to make sure to count the ticks. Don't just look at the fact that there are ticks. Make sure it's the same number of ticks, okay? Okay, here we have the values of the sides. Again, we know it's sides because there's no degrees, and then if it's angles, they would be written, say, like that. Okay. So I have a 35 and a 35. I have a 19 and a 19. If I want these to be congruent, these need to match. So x has to equal 28, and then they'd be congruent by side, 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 because it'd have 3 sides. Okay. So right now, you're going to either have 3 sides, which gives us the side, side, sides. You'll have 2 angles and 1 side, which will give us that angle, side, angle. Or you'll have 2 sides and 1 angle, which gives us that side, angle, side, so far. And so when we're looking at these to determine congruence, when I look at A, I'll say, oh, those are 2 sides. Okay, so I either need the 3rd side or I need an angle, because I have 2 sides, right? So, and then I go, okay, look, here's this angle and that angle. Cool, they match, side, angle, side. So that's another way to look at it. Here I have 1, 2 sides, so I need either the angle in between them or the 3rd side. Well, the 3rd side's being shared, so it's side, side, side. If I had another picture with 2 angles, as soon as I see that there's 2 angles, I say, okay, I need that side in between them, so they would have to have this marked in order to be congruent and be angle, side, angle. And if they don't have that, then it's not congruent. Right now we have angle, side, angle, and if I had this with nothing marked other than that, I would have not congruent. Because I don't 100% know that these are the, even if they look the same on the picture, until they're marked, I can't say that these 2 sides are the same length. I don't know why I pushed that button. Really. Okay, so things that we're going to need. We're going to need those, we need 3 parts. Okay, out of the 6. Every triangle has 6 parts, 3 sides, 3 angles. We need 3 to be congruent. Okay, right now we need 2 sides and an angle, 3 sides, or 2 angles and a side. Okay, and this would give me side, angle, side, 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 and angle, side, angle. Okay. The proofs are going to be generated the same as the ones we had done in term A, so we're going to be given statements, or 1 or 2, and then we need to find, that's an N, missing sides or angles. Okay? Or 2 sides, 2 angles and a side. Okay, so we're going to be given statements, and then we're going to need to find the missing information. Okay? Things that we're going to be using in these proofs, things that will come up a lot. The reflexive property. When 2 triangles are sharing a side, you say side AB is congruent to side AB, reflexive. Okay, we'll use that a lot. Vertical angles. Okay, so remember, whenever there's an X, so if you've got 2 triangles being joined together like this, our vertical angles are going to be congruent. We're going to use that a lot. Okay, midpoint or bisect. Sometimes we'll have two triangles, and our given statement will be like this line bisects this line. And we know if it bisects, it's been cut in half. So that would give us these sides, and then we'd have congruent vertical angles. So we'd have side angle, side, things like that. So midpoint and bisect will come up a lot. Vertical angles will come up a lot. Reflexive will come up a lot. The fact that triangle angles add up to 180. Okay, because if we're given the measures of two angles, we can find that third one to see if they're congruent. So we'll use that. A pretty good list of what we're going to be seeing a lot right now. So for a quick review, reflexive property is everything is congruent to itself. Okay, so angle A is congruent to angle A, reflexive property. Side AB is congruent to side AB, reflexive property. So if they're sharing a side, sharing an angle, this is what you'll use. So sharing, okay? Vertical angles, again, if you make an X, the angles across from each other are congruent. Midpoint and bisect, cuts in half. Okay, so the equal halves. Anybody need me to go over any more of these at all, or is this okay so far? Upside. Oh, this one, the upside down T, this means perpendicular, sorry. Yeah, so you don't have to write out the words. This means perpendicular, and then if you do that, it's parallel. Just triangle. Yeah, just triangle, so you don't have to write out the word. And then these are angles. Yeah, triangle angles add up to 180. And then you got right angle, perpendicular, complementary. Complementary are two angles that add up to 90. And then just since we're going over it, supplementary are two angles that add up to 180. Once you know the symbols for like parallel, perpendicular, congruent, you never have to write the words out anymore. Which is why they came up with the symbols to begin with, because mathematicians don't like to write a lot. All right, we're going to do a proof. We're going to walk through this together. What is the first line of every proof always? Given. Okay, this information has been given. BW is congruent to XW. Check the picture. Is it marked? VW, XW. Awesome. Then I'm also given that UW is congruent to YW. So also given. Now, without even taking these into consideration yet, I'm looking at this picture. Just look at the picture. I know these two sides are congruent to each other. What else do I absolutely know is congruent? Yeah, those are already marked. I meant things that are not marked. These two? I don't know that they're congruent. I don't have any reason to know that those are congruent. Vertical. Yeah. That's what I was looking for. I know because these are forming an X, right? Because these are forming an X, I know that these two are congruent. And I know that they're congruent from vertical. They're vertical angles. Okay? Now, I have two sides and I have an angle. When I had those two sides, I knew I needed either that third side or that angle. The third side didn't work. I didn't have any way to show, but I had the angle, so I have side angle, side. Yeah, this is one triangle. This is the other triangle. Uh-huh. Yeah. The last line of these proofs is always going to be one of these reasons. Side, angle, side, 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 angle, side, angle. Or when I give you the other ways that triangles can be congruent. That'll be the last line. It's always going to be one of these. You're going to be given something, and then looking at what you're given, I said, okay, look, I have two sides. I either need that third side or the angle in between them. Oh, look, I'm making X and vertical angles. Hey, look, I got that right there, done. Okay? There's not a lot of creativity with these proofs. There's not a lot of crazy things that you can do. They're very sort of, yes, there's only so many ways they can go. Things are going to bisect each other. Okay, what does that mean? Oh, that means these two parts are the same length. Oh, look, I have side angle side or side 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 or whatever. You know, it's going to be, there's not a lot of ways that they can go. If I didn't have these angles vertical, if I had, say, these two triangles were just like this, and they, pretend that's one, and they weren't touching, I would have to have been given some other information. There's no, if I had just this picture without those vertical angles and I hadn't been given any more information, I wouldn't be able to go anywhere with it. I wouldn't be able to prove that they're congruent because I have no way to show that these two are congruent. So I can't do side, side, side. If we're doing bisect, let's say same picture, but instead of telling me that these sides are the same, my line up here, my given line, would have been that VY bisects UX, like that, which would have told me that UW is congruent to WX and VW is congruent to WY. Because bisect means that they would have cut each other in half. So that would have meant that this line was being cut in half, which would have made this side and this side the same. And then if this line was cut in half, these two would have been the same. So it would have changed which sides were the same, but it would have resulted in the same general kind of thing. I said, okay, these are bisected. That means they're cut in half. That means they're the same length. And then vertical angles, and then side angle side. So what I would like to do is if you go to the homework page for this, there's 3 proofs on there. And I did not give you guys the